So have you all read the lab manual? Okay, so basically today we are going to discuss on the error analysis. Okay, so error analysis is the most important part before you start doing the any real measurement. All right, so basically the error analysis involved with the uncertainty on the measurement or the data set that you recorded from your experiment. Okay. All right. So in this lab session, you're going to learn on how to record a repetitive data set from an online experiment to perform the error analysis. Okay. And also to report the error to the correct significant figures. Okay, and to report the error of some different product and quotient of two measured quantities. So basically, if you have variable of x and y, then how you want to report the error? Okay, so you should learn that. Okay, you should also know how to report the error in terms of power of a measured quantity and composed expression. Okay, and then you also need to calculate the mean of the recorded observation and find the standard deviation. So to quantify your error, it is standardly accepted that you must use the standard deviation to report the error. Okay, so you will know, let's say you are given a mean as 1.2, okay, and plus minus, okay, that's after that will be your standard deviation. Let's say 1.1 plus minus 0.2. Okay, so your standard is 0.2 and your mean is 1.1. Okay, and lastly, you will be able to explain on the plot of Gaussian distribution. So if you learned before in the mathematics, the Gaussian distribution is a bell-like shaped graph. Okay, the Gaussian is also known as the normal distribution. Okay, so basically the center where the peak lies the mean of the measurement. Okay, and we will also discuss about that later. All right, so for the introduction, okay, so basically, so you should already have read this. So what I want to stress that, so let's say we have an example. Okay, so let's say a policeman want to detect the velocity of a car using the speed track gun. All right. So, but the speed track gun has the level of accuracy of 10 miles per hour. Okay. And then suppose that on a street, the speed limit is 35 miles per hour. And then he stops a car which, according to the speed track gun, is going to be 40 miles an hour. Okay. So as it is mentioned above that the error, the accuracy is 10 miles per hour. So it can be, the range can be within 30, all right, because you get minus 10 from 40. So it can be 30 and it can also be 50 at the maximum. Okay, so the range is very big. So it is between 30 to 50 miles per hour. Okay, because of the imprecision of that gun, all right, so the actual The car velocity, as I said, is between 30 to 50. So the policeman cannot really give a summon ticket to the driver, okay, because maybe the car is driven at 30 miles per hour, so it has yet to exceed the speed limit of 35 miles per hour. Okay, but if the accuracy of the gun is just between 1 mile per hour, so which is when it detects at 40 mile per hour, so the accuracy, I mean the range is just between 39 mile per hour to 41 mile per hour. So he can give the ticket. All right. So you see that. So the difference between the uncertainty of the measured data from the instrument. So if the highly accurate instrument have a very low uncertainty, okay, as you can compare, okay, from previously it has uncertainty of 10 mile per hour, and now the uncertainty is 1 mile per hour. All right. So I hope you're clear with the concept of the uncertainty. Okay. All right. To report the error, so we're now going to the number 2. So we usually present that in terms of x plus delta x. Okay. So it can be in either notation. So you have the triangle notation, or you can have like it's called the delta sign. So it's a little bit curvy. Okay. So it is like almost a beta or alpha for the delta sign. So you have that. So that x is the measured value, and plus minus, okay, plus minus the uncertainty. So that delta x is the uncertainty. Okay. All right. What is important here? Let's say you want to report the error. Okay, let's say your measured data is 100. Okay, and then plus minus 5. Okay, it cannot be 5.1. All right, it cannot be 5.2, or it cannot be 5.31. Okay, it just can be a single digit number, because 100 is a round number. Okay, so because 100 is a round number, so you must follow what is the main measurement value when you are going to write the uncertainty. Okay, so other example, okay, you can see that on the last paragraph. Okay, let's say 11.3, so you can have plus minus 0.2. Okay, it also give you an example. Let's say 11.3 plus minus 5 does not make much sense, right? Because it is not useful because of the different decimal digit, okay, which you also call that number in terms of the significant figures. All right. So let's say 11.3 have 3 significant figures. Okay. So the uncertainty should also be in terms of 3 significant figures. Okay. So that is how you need to report your error. Okay. You might also have, all right, more than one quantities to be measured. Let's say you also have X and Y. So this is uh, what we call as the propagation of errors. Okay. All right. So why that happen? Because sometimes we can measure the certain quantities directly. Okay. But more often we need to use the relation to find the result that we want. Okay, for example, it is given there. So we have that we want to measure the volume of a rectangular box. Okay, and then we do not measure the volume directly. So we must measure the different edges first. Okay, and then we need to multiply the results to find the volume. Okay, so let's say you have a box. Okay, you have a box, so it is in 3D. Okay, so it is in 3D, so you have X, Y, and Z. Okay, so you have different uncertainty for each of those different edges. So let's say your length is X, so your width is Y, and your height is Z. Okay, so you have X plus delta X, Y also plus delta Y, and Z plus delta Z. So you have uncertainties for both for all of those three quantities. Okay. All right. So in that case, we need to understand on how to quantify the error associated with the quantity you wanted to measure in the first place. All right. So that is our volume. All right. So that process is known as the error propagation. Okay. So okay, let's say we have more specific error propagation. So first we look at the error of sum and difference of two measured quantities. Okay, for example, we have X and Y. Okay, so let's say we got S is addition of X and Y. Okay, and then S can be as big as, because X can plus delta X, and then plus Y plus delta Y. Okay, and then it can be also minus. All right, it can also be minus because let's say X minus Y. Okay, sorry, no, it's still X plus Y, but because of the uncertainty is X. Okay, X plus minus delta X, and then Y plus minus delta Y. So you have the minimum uncertainty and also the maximum uncertainty. So maximum will be plus delta X and plus delta Y. And for the minimum, it will be minus delta X and minus delta Y. Okay, so it can be as small as X minus delta X plus Y minus delta Y. Okay, so when we combine those, right? When we combine those, so we have X plus Y plus delta X plus delta Y. All right, and then S is between. Okay, that is the maximum. All right, and then for the minimum will be, you rearrange back. So X plus Y minus delta X plus delta Y. Okay. All right. So therefore, the uncertainty in S Okay, because the real measurement is x and y, right? So the uncertainty is S is delta S. Okay, so you have the plus and minus sign at delta X and delta Y. So it is that delta S is equal to delta X plus delta Y. Okay. Alright, so similarly, when we look at the subtraction, okay, so it can be as big as x, let's say we have d equals to x minus y. Okay, so we have x minus y plus delta x plus delta y, and can be as small as x minus y minus delta x plus delta y. Okay, and then similarly, the uncertainty is still similar. So you have the delta d equals to delta x plus delta y. Okay, so we can summarize that delta x, okay, delta in the bracket x plus minus y, okay, will be equals to delta x plus delta y. Okay, so that means the error of the addition of two numbers or subtraction of two numbers will always be delta of one number and then addition with another number. Okay, so you know here that the error associated with the difference of two measurement is the sum, okay, not the difference, okay, of the errors associated with each one. Okay, so we need to just remember that the errors is just add up when we increase the measurement. Okay? When we increase the measurement, so the error is always add up. Okay, now look at when we need to multiply both of the quantities. Okay, let's say we have p equals to x, y. All right, so as usual, so we have the uncertainty of x is delta x and y we have the delta y, and then we want to calculate the uncertainty in y. You want to calculate the uncertainty in p. All right, p can be as big as, okay, so when we multiply, so we have x times y. Okay, so for that x, you must expand that. All right, so x plus delta x, okay, and then put that in the bracket, multiply with, in the bracket, y plus delta y equals the bracket. Okay, so you need to expand those expression. Okay, so how to do that? So x times y, all right, and then x times delta y plus delta x times y plus delta x times delta y. Okay, so you have the expanded expression. Okay, and then when you do the, okay, so for the minus term, so x minus delta x in the bracket, and then multiply with, in the bracket, y minus delta y. Okay, so you have that xy plus x delta y minus y delta x plus delta x delta y. Okay. All right. So we can assume that the delta x must be much smaller than x, and delta y must be much smaller than y. All right. So in this case, all right, when we do the multiplication uh, of both delta, all right, so we will get that term very small. All right. So it is not similar like the addition. The addition, we cannot consider it very small. Let's say, okay, we give an example. All right, so let's say the delta x is 0.1, okay, and delta y is 0.2, okay. So for the addition, it will be 0.3. But for the product of that, it will be 0.02. So it is very small. So that's why we can neglect the term of the product between those two uncertainties. All right. So for both delta, so multiplication of both delta, we can neglect that term. All right. So what do we have? So when we neglect that, so we have the P is between xy minus in the bracket x delta y plus y delta x. And for the maximum P value, it can goes up to xy plus x delta y plus y delta x. Okay, so we can define that the delta P is, okay, the term of x delta y plus y delta x. Okay, so that's the delta P. Okay, and then if we divide that, okay, if we divide that with xy, okay, because xy is the P. All right, so the delta P over P is equals to delta x over x plus delta y over y. Okay, so that's the uncertainty. Right, so that's the uncertainty for the product of two measured quantities. Okay, so let's move on to the quotient. All right, what is a quotient? So quotient is the division of the two numbers. All right, so for the division of two numbers, so let's say we have q equals to x over y, and then as usual we have the uncertainty of x and y as delta x and also the delta y. Okay, so we can calculate the uncertainty, all right, by writing that we have x, y minus 1. Okay, so we rewriting the equation as x, y minus 1, and then we use the previous result for the uncertainty associated with the multiplication of product and the power. So I haven't explained the power. So basically it will divide the x, okay, divide x by y. We find that, so we have like this term, okay, the delta p over p. So we have the similar term as the product. So we have, so we put there, so delta x minus y1, which is delta q, all right, and then divide with the q. So we have that delta x over x, and then plus in the modulus is minus 1, and then delta y over xy. Okay, so simplify that, we have the delta q over q, delta x over x plus delta y over xy. Okay, so before that, so you can do the expansion, all right? You can do the expansion like in the product to get the term here, all right? Okay, but before that, we need to look at the errors. So how you get the second term, all right? So how you get the second term, because the first term, okay, it is straightly forward, which is the delta x over x. Okay, and then the second term on the quotient, so you have delta y over x y. Right. Okay, so we look here. Right, so let's say we have the uncertainty in the quantity of p equals to x n. Alright, so the x n, so n can be 2, 3, 4, 5, 6, and so on. Alright, so as usual, we have the uncertainty as the delta x, and then so let us write the xn as the product of x with itself for n times. Okay, so since we know how the errors propagate in the product, we can calculate the error in p as, okay, so we have delta p over p is equals to delta x, all right, over x plus delta x over x, and plus the same term again and again and again until the number of n times, which is equivalent to the power of your x, right? So let's say if x to the 4, so you have only 4 times of delta x over x, and then this will be equals to n delta x over x. All right, so you have that. So let's say for the example I give previously, so it will be 4 delta x over x. Okay, so that's the power in the measured quantity. All right. All right. One more thing about this power. All right. This formula is always valid, even n is not positive or n is not an integer. So what does that mean? Right. So let's say your n is -1. All right. So that's also valid, or it can be -2, -3, and so on. So that is still valid, meaning that you just multiply that. You just multiply that with the n term as that power. All right. So let's say you have the previously you have the y -1. All right. So what should be the uncertainty or the error? So it will be -1. So it will be -1 delta y over y. All right. So that's how you use the power, all right, to quantify the error. Okay, it can also be a non-integer, such as the power. Let's say I give the example is x to the 5.3. Okay, it is still valid. Okay, it is still valid, meaning that the n term will be 5.3 delta x over x. Okay, so it will be as simple as that. Okay, let's say we have the combination of expression. Okay, let's say we have addition and also the multiplication. For example, we have, okay, over here uh, x cubed plus y squared. So as usual, we have the uncertainty of x is delta x and uncertainty of y is delta y. Okay, so we find out, let's say we expand that. So we expand that because it is like the power. So it is, let's say it is x times x times x, all right? So we have x plus delta x in the bracket times x plus delta x in the bracket and x plus plus delta x in the bracket. So you have that, okay? So it is just basically the multiplication of the delta x, all right? And then plus delta y. So we can look here. So delta y is similar. So we have y plus delta y in the bracket, okay, and then to the power of 2 because it is the same term that we multiply. So we can define that, right? So we can define that delta in the bracket x cubed plus y squared equals to delta x cubed plus y squared. Okay, so we can now, okay, notice that it is in the expression of power. Okay, so we can expand them. So we obtain that delta x cubed plus delta y squared equals to x x cubed 3. So we take out 3. So that's the n term. So 3 delta x over x plus y squared 2 delta y over y. Okay, so we get the expression of, okay, 3, okay, 3x squared delta x. Okay, so when we cross x, okay, so when we cross x over here, so x cubed over x, so we get x squared, okay, and then y squared over y, so we get y. So that's why you get this term. So the result will be x cubed plus y squared. So it will be equals to 3x. Sorry. So this should be x squared. Okay. Delta x plus 2y delta y. All right. So we have couple of preliminary questions over here. So right now, this is the task what you should do. So we have 9 questions over here. All right, I'm giving you about 20 minutes to answer these questions. Okay. By the time I will stop talking and then you need to do this question. All right, any questions so far you can ask? Any question? So right now you thought your task is to do this number 4 preliminary question. So please be familiarize yourself with this. Okay. because I'm going to ask you what's the answer after that 20 minutes. Okay? Are you guys with me?
Yes.
Yes.
Yes, doctor.
Okay. So you guys any problem to access the document? So the document is already shared on the WhatsApp group and also on the Putra Plus. So you can just download with either method. And we also have some students from the Dr. Farah's group. So are you guys okay?
Sure.
Okay, so we will, okay, I will give you time to do the questions. So we will start again at 9:20. So where I will ask you on how to do the problem. So basically this is what will be accessed, all right, for your psychomotor skill, all right. So because we have from all of you, so we have 21 students registered for this. All right, so please be prepared. So I will ask each of you a specific question. So you need to be prepared. Okay, so please answer all of this, all of the questions, and then all right, and then I will come back at 9:20 to discuss with you all of those questions.
When you try your best but you don't succeed. When you get what you want but know what you need. When you feel so tired but you can't sleep. Stuck in reverse. And the tears come streaming down your face. When you lose something you can't replace. When you love someone but it goes to waste. Could it be worse? Light will guide you home and ignite your bones. And I will try to fix you. High up above or down below. When you're too in love to let it go. But if you never try, you'll never know just what you're worth. Light will guide you home and ignite your bones. And I will try to fix you. Tears stream down your face when you lose something you cannot replace. Tears stream down your face, and tears stream down your face. I promise you I will learn from my mistakes. Tears stream down your face. Lights will guide you home and ignite your bones. And I will try to fix you.
Okay, so are you guys finished? Okay, we will go through. Okay, so for the first question, okay, Elia Natasha. So what's your answer?
For the first question, I got it as wrong.
Yes, which one?
Yeah, I'm sorry, doctor. Do you want me to answer A until E or just A?
All of that, because some of that are correct and then some of that are wrong. So
Okay.
let me know which, let's say A and B are right. So and C, D, E and wrong. So you should answer like that.
Okay. For A and B, I got it as wrong, and C, D, E, I got it as correct.
Okay, that seems not correct. Okay, so okay, the first one. Okay, we look back. Okay, for the first one, A is 110 plus minus 10. That should be the correct one. Okay, because it is using the significant figures as the measured value. So as I said, let's say 110.1, then it should be 1.1. That should be correct. But if 110 plus minus 1, that also should be correct. But this one is using 10, so it should be correct as well. So do you get that?
Yes, doctor. Thank you, doctor.
Faham tak? So let's say we have 100 and then plus minus 20. That should be still correct, but the errors are big. Okay, it is a correct way to report the value of measurement. Okay, so let's go to B. B is wrong. Okay, B is wrong because you look at the uncertainty, it has 0.2. Okay, it has 0.2. So that is not correct because the main measurement value does not have point number. All right, so it is a whole number. Okay, C is correct. Okay, so you got it correct. Okay, and D is wrong. Okay, so D is wrong because you should have uncertainty of point X and X. So let's say 8.33. So plus minus should be 0.21. Or it can be 0.01, or it can be 0.05, or it can be 0.11. Okay, so D is wrong. Okay, and E, so E is correct. Okay, so you have the 3 digits after the point. So 3 digits after the point. So that is correct. So A is right, B is wrong, C is right, D is wrong, E is right. Okay. Okay. Sorry. Number 2. Okay. I'm going to ask Alif. Alif Azrai.
Yes, doctor.
Okay. So which are correct? A to E.
Choose D, doctor.
B.
D is correct and the rest is wrong.
You mean D for doll? Denmark.
Yeah.
Okay. You still don't get the concept. Alright. Macam mana saya nak cakap ah?
How about C and E?
Yes, you got it correct. Okay, so Kailian got it correct. So how do I explain to?
We have
You
to
can
first.
explain.
But I don't know my explanation is correct or not. You can correct me if. Okay. So what I did is I observed the uncertainty first. Yeah, I see the decimal point of the uncertainty, and then I will look at the measure value. That means I observe the uncertainty first. Only I go to the measured value, so that it's easier to determine whether it's correct or not. Because let's see for C, right? We have 0.001 as the uncertainty, and then we look at the measured value. The decimal points is the same as the uncertainty. So this is how roughly I determine the answer. Yeah, something like this, but I don't know whether it's correct or not.
Yes, it's a good explanation. It is actually very simple. You look at both measurement, all right, measured value, and also the uncertainty. Okay, so if both having, let's say, for example, C, so it has 4 significant figures, and then also uncertainty also have the 4 significant figures over there. All right, so that is correct. Okay, it is very simple. So, for example, you have 5.2, such as in B. So the uncertainty should be only 0.1. It's not should be 0.001. Okay. And also A is not correct because you don't have the units there. Okay. So others have got unit, but as Kailiang said, so we have only C and E are correct. Okay. So the rest are wrong. So you guys got that? So because this is very basic, so you need to make sure that is right before we can proceed further. Okay, okay, I'm going to ask all of you. All right. Okay, Shahrul Azli. Okay, I'm going to give you a measured value, and then you need to tell me what is the uncertainty, the correct uncertainty. Okay, let's say I give you the value at 3.22. So what is the uncertainty for that?
0.01.
Okay, so you got it correct. Okay, that's good. Okay, Atika. So let's say I have 4.002. So what is the uncertainty for that?
0.001.
Okay, that's also correct. Alif, okay, I'll get back to you. So what is the uncertainty of 10?
Plus minus 1.
Okay, that's good. Syaziatul. Alright, let's say the number is 10.01.
Plus minus 0.01.
Okay, that's good. Azrin Shah. Okay, I'm giving you, let's say, 20.0. 20.1. So what's the uncertainty?
And the uncertainty is 0.1.
Okay, it's good. Okay, Balkis, 3.1. So what's the uncertainty? Siti Balkis?
0.1.
Okay, that's good. Okay, Syahidatul Azira. So let's say I have 110.0. 0.001.
Zero point zero zero one.
That's not correct. Again, you try 110.02. So what is the uncertainty?
Plus minus one.
110.02. So basically you have 110.02.
0.01.
Okay. Okay, that's good. Okay. Who else? Alright, Akil, I asked you?
Not yet.
Okay, so let's say 33.33. So what's the uncertainty?
0.01.
Okay, that's good. Aliatul Husna, let's say I have 2.002. Aliatul?
Plus minus 0.001.
Okay, that's correct. Okay, Lim So Sim, let's say we have 11.1.
0.1.
Okay, that's good. Okay, Amin Faris. So let's say I have 2.2.
0.1.
Okay, that's good. Shahidatul Mashita. Let's say I have 6.01.
0.01.
Okay, that's good. Tamjai, let's say I have 3.3.
Plus minus 0.1.
Okay, that's good. Okay, Syarul Azli, let's say I have 1.13.
0.01.
Okay, it's good. Okay, Atika again. Let's say I have 5.2.
0.1.
Okay, it's good. Amirul Ramlan, let's say I have 4.44.
0.01.
Okay. Okay, let's say I have the uncertainty. Okay, now I reverse. Let's say I have the uncertainty of 0.02. So what is the correct measured value? Nurul Shazwani. I have uncertainty of 0.02. So what will be the measured value?
Doctor,
Mhm.
can I say any of the number?
Yes, you can choose any of the number.
0.02 eh?
Yes, the uncertainty is 0.02. So what is the measured value?
1.51.
Okay, great. That's good. Okay, so Nosafia Melati, let's say I have the uncertainty of 2. So what would be the measured value?
4.
Okay, that's good. Okay, Munira, okay, the last one. So let's say I have the uncertainty of 0.3. Munira, are you there? Munira, I see your cat is sleeping. Okay, so what is the uncertainty for the measured value for the uncertainty of 0.3. Okay, it's okay. So I think she has got the problem with the internet connection because I just saw her going in and going out. All right, so basically one more thing I want to state that the uncertainty cannot be bigger than the number. All right, so let's say you have the measured value of 4. So you cannot have the uncertainty of 6 or 5. Okay, so it cannot be 4 plus minus 5 or plus minus 6. So the maximum should be less than that number. Okay, so 4 plus minus 3, that should be okay. All right, so I hope you get the concept. Okay, so we have number 3. So we have number 3. You need to find a formula to find the error associated with the square root of a quantity. Okay, so this number 3 for a square root of a quantity. So let's say you have b equals to square root of x. Okay, so how should you transform that? All right, so how should you transform that? So you look back at the document. All right, so you have the square root can be mentioned also as half. So can be b equals to x 0.5 or x 1 over 2 to the power of 1 over 2 or to the power of 0.5. So later you have the uncertainty of that as half, all right, half of that delta x, all right, so I mean that is 0.5 delta x. Okay, so that's the uncertainty for that. All right, so you need to write those these preliminary questions into your lab report later. Okay. Okay, so basically I won't go through this one. Okay. All right, so you guys have any problem with other questions? So you have difficulty to answer any of those questions. If you have difficulty, so you can let me know, because I want to proceed now with the experiment, with the online experiment. So if you have problem to answer that, so let me know. Because today we're gonna have 3 experiments to be done. And I'm going to show you how to do that. So for the rest of time, you can take your time to do that experiment. Okay, let's say we go to the experiment 1. Okay, on the pendulum. Okay, we go to the simulation. So firstly, we open on the simulation. You can click on the documents. So let me share my screen. So basically, this is what you have when you open up the link on the experiment 1. So you click on the intro. So basically, you have the pendulum. Okay, so what you need to do is, okay, you need to first set the length of 1 to 0.9 over here. Okay, so it will increase, as you can see, it will increase the length of the rope of the pendulum. Okay, and mass, so you can make it small or big mass. Okay, so as I stated in the document, so we set it at 5, and then we set the gravity, okay, the gravity to the moon, right? And then we use the cursor over here, so to move the pendulum, okay. So from the document, it says we need to have the pendulum away about 70 degree from its equilibrium position. Okay, so all right, before that, we need to click on the stopwatch. Okay, because your task is going to record. Okay, record the time for this pendulum to swing. Okay, from this location. Okay, from this location, and then come back to its original location over here. Okay, and then you need to record the time. Okay, so let's say I do the first one. I won't because why I choose gravity as the moon, because if you don't have the friction, okay, if you don't have the friction, then the pendulum will swing all the way. Okay, it will swing all the way, and then it won't stop. Okay, it will always come back to its initial position where you release the pendulum. Okay. Okay, so let's stop the pendulum. Okay, so let's go back to the 70. Okay. Once you go to 70 and then release the pendulum. Okay, what you need to do is record the time. Okay, now record. And then stop. Okay. And then record the time in a piece of paper, because we're going to make a couple of measurements as we need to take 20 measurements. All right, we need to take 20 measurements. Okay, let's say I record for the first one. Okay. Okay. I get it at 5.02. Okay. So 5.02 seconds. So you need to write that on a piece of paper. Okay, I reset back time. Then I wait for the pendulum to reach again on its initial position, and then I do recording again. Okay, now I record and then stop. Okay, now I obtain 5.20. Okay, so now I record again 5.20. Okay, and do that for the rest of another 18 measurement. Okay, so you need to record that. All right, and then we need to calculate the average of that. Okay, we need to calculate the average of that. So let's say now you have 20 measurements. So this equation, so your n will be 20. So you add up 5.02, 5.2 plus 5.1 plus 5.15 plus 5.03 and so on until 20 measurement, and then you divide that with 20, so you obtain the average value. Okay, once you get that, and then you need to find out what is the deviation of the measurement that you took compared to average value. Okay, so the deviation is calculated for every number. So for example, you obtain your average as 5. Okay, so let's say for the first one you have 5.02, so the difference is 0.28, and then for the second one your measurement is 5.2, so the difference is 0.1. Okay, so you calculate all of that. All right, all of that, and then you divide with 20 to find the average of the deviation. Okay, for let's say you have that as 5. Okay, so if your mean, if 5 point, let's say again 5.5. Okay, so you obtain the value of 5 point, at the first one 5.05. Okay, so the difference is minus 0.45. Okay, and the second one you obtain 5.2, so the difference is minus 0.3. Okay, but you have a bigger number you obtain for the third measurement, which is 5.6. So the deviation now is positive 0.1. So you sum all of that. So you usually will get the answer close to 0 because of what? Because you add up negative and positive numbers together. All right. So using this method, using the deviation method is not correct. Okay. Using the deviation method, it is not correct because you won't get correct error measurement from your data set. Okay. So what you need to do, you look at number 9 on the lab document. So we need to find out the standard deviation, which is the given by the equation in number 9. So you need to square all of those deviation that you calculated. Let's say for the first one you have the deviation of 0.3. Okay, of 0.3. So you square that. So you obtain that as 0.09. Then for the next one, you obtain the deviation as 0.1. So you square that, so you obtain the square of deviation of 0.01. Okay, you sum up all of that for 20 measurements, and then you need to divide by 20 minus 1, which is n minus 1. So you divide with 19 numbers, and then you square root all of that, and then you will obtain what is your standard deviation. Okay, so you need to report that, and then the average of the error, okay, which is the average of the standard deviation. So you have the standard deviation, again divide that with the square of n, which is square of 20. Okay, so you got the error of the measurement. Okay, this is the average standard deviation is the uncertainty. Okay, is the uncertainty in your measurement. Okay, so to write that, so you look at number 11. So T will be equals to your average measured value, which is, for example, 5.5 plus minus. Maybe you obtain that as 0.1. Okay, but if your value is 5.0, so your average standard deviation may be plus minus 0.03. Okay, so you need to write it that way. Okay, last but not least, for the 12, for the number 12, you need to repeat the step number 3. Okay, step number 3. Okay, basically you're going back to this. Okay, you're going back to this initial instruction. What you need to do is you need to increase the number of recorded times to 20. Meaning that you need to take another 20 more measurement. Okay, and then you need to recalculate the standard deviation and also the average standard deviation. Okay, so you compare that, the previous standard deviation to the new one, to the new standard deviation. What happened to that? Okay, it is bigger or it is smaller? Okay, so also what happened to the error of the average? Okay, which is the standard deviation average. Okay, you need to look at that, whether it is smaller or bigger. All right. So when you increase your measurement, so that will affect your standard deviation. Okay, so that's for the experiment number 1. Okay, so let's move on to the second experiment. So I hope that is clear for the experiment number 1. All right, so you have any question? Okay, so let's proceed to experiment number 2, which is the curve fitting. Okay, so basically, so we go to the second simulation. Okay, so basically we need to click the values, all right, and then we need to drag this point, okay, from the bowl and place it on the XY graph. So according to the value that is given in 1, all right. So over here, let's say we have X minus 5.8 and Y at 7.1. Okay, so over here, so Y is at 7.1. Okay, so it's there. And then you put it for the second one, it's minus 3.6. And then you have 3.8. Okay, over there. And then the third one, 0.8. 1.1. Okay. And then we have 2.3 to minus 3. Okay, it's there. And then we have 6 minus 4.1. And then 6.2 minus 7.6. Reach there. All right. And then we need to take the curve. Okay, and then need to record this equation. Okay, and then need to toggle between all of this. Right. So which one is the best fit? Okay, so you need to explain that. So you need to choose which is the best fit. Either is linear, quadratic, or cubic. Okay. And then suppose you are given the equation as in 5, x equals to 3 pi over b y. Right, so you need to find what is beta. So basically you already have the equation, so you need to plug in and then find out what is your beta. Okay, so next one, so you have the between x and y given as follows. All right, so you need to find out what is the error. Okay, what is the error? So you need to find out. So first you need to reset this plot. So this is actually the reset button over here. Okay, so you again click on the curve. So you actually, sorry, you need to click on the values. So you have C2, X is 2 and Y 0.5. All right, so and then repeat again until you have those 12 measurements. And then what you need to do is to find what is A in the equation. All right. And then what you need to do is to do the linear plot. Okay, you need to do the linear plot. And then you need to find the error. Okay, you need to find the error of A as well. And then also you need to find out what is the Q and also the error from the linear plot. Okay, that is about for the experiment number 2. Okay, and then for the last experiment, we going to assess the error in terms of Gaussian distribution. Okay, so let's say we have those 12 values. Okay, and then we need to find out what is the mean for all of that. Okay, so what is the mean for all of that? And then B, we need to calculate what is the standard deviation. All right, so the formula is already given in the experiment 1. So you refer back to experiment 1. And then we need to find out the distribution of the measurement. Okay. Whether it follows the Gaussian distribution or not. Okay, so we go to the web. Okay, so basically this is what you will get. Okay, so what you need to do is to insert the mean value. Okay, let's say you obtain from these values, you obtain the mean of 9.98, and then you obtain the standard deviation of 0.12, and then click update. All right, so you obtain those two numbers. For the green numbers, so you look back at the Gaussian graph. So you need to write down what is the lower green number. So for example, here we have 9.86, and then the bigger green number is 0.1. Okay, so you notice that at the bottom it mentioned at 0.1587. Okay, if you multiply this, right? If you multiply this, did you notice that? You notice that this value is actually at the standard deviation from the mean. Okay, let's say you have 9.86. Okay, so 9.86 plus 0.12, so you obtain 9.98, and 9.98 you plus with 0.12, so you obtain 10.1. Okay, let's say you change the standard deviation to 33. Okay, so you update that. Okay, so now you obtain different values. So what you get over here, okay, so you have actually it's 0.33, okay, 9.65 plus 0.33, so you obtain 9.98, and then 9.98 plus 0.33, so you obtain 10.31. Okay, what does that mean? Okay, so it means that you have 0.1587, which is equals to 0.16. So you multiply that with 2, so that is the 32% of the measurement. Most 32% of the measurement are within the what we call within the standard deviation. Okay, so the rest of that mean that in the yellow color of the graph, it is outside of that standard deviation. So in terms of statistics, it's called as this yellow area is considered as outside one standard deviation. Okay, if it is inside the white one, so it is the value, all of that are inside one standard deviation. Okay, so how to get it better, right? So you can define if your measurement is better when you have the most of the measured value are within the wide range. Okay, so for example over here we adjust the standard deviation to 0.1, and then we look. Okay, so many of the measurement will lie on the white curve, right? We lie inside the white curve. So because that one will be more correct values of the measurement. Only the values that are located on the yellow area are the one that is outside the standard deviation. So for example here, so we have, as I said, okay, so let's go back to 0.33. Okay, you look back at number 1. Okay, so you have the value at the first one is 9.04. That value is outside of the standard deviation. Okay, that value is outside of the standard deviation. Alright. So that is not a good value because it actually it deviates much from the mean. Okay. Okay, and then look at the 9.64. It is a good value. No, it is not a good value because it's more than the 1 standard deviation. Okay, and then you access more and then look which one of the values are within the standard deviation. But over here, I make the mean seems not correct. So let's say we adjust that. Okay, let's adjust that. So I put, let's say, 9.46, okay, and then we update, and then okay, now we look back at the number 9.04 is still outside. 9.64, yes, it is inside, so it is a good value. And 10.5 is not good value because it's out of range within the 1 standard deviation. 8.66 also good value. 8.77 not a good value. 9.54 it is a good value. Okay, and 6.54 it is not a good value because that is a long way from the mean. Okay, and then you need to look for all of other numbers as well. Okay. All right, so that's basically about the that number 5. Okay. All right. So to what percent of the total 12 measurements does the answer to question 15 correspond to? Sorry, it's question 5. Should not be 15. So that's question 5. So you need to check. Okay, as I said from here. So how many of that? Let's say you found out from this, 4 of that are out of the range. I mean, outside of that 1 standard deviation. So you need to find what is the percentage of that. Okay, so 4 over 12 times 100. So you get that. So 4 over 12 is 3. So 33.33%. Okay. 33.33%. And then you need to answer back whether this value indicates that is a Gaussian distribution. Okay, that is a Gaussian distribution. Okay, so what is a Gaussian distribution? A Gaussian distribution is most of the values are centered to the mean. Okay, so if most of the value are within the mean, so that is a Gaussian. But if the values are scattered, all right, so maybe you don't have a really good graph, so that is not a Gaussian distribution. So maybe the bell will be flat. Maybe will be flat, so that is not called a Gaussian distribution. So for the Gaussian distribution, so the shape should be mostly likely a bell shape. Okay. All right. So that it is for the number 3. So I hope the instruction is clear. All right. So you can start doing the experiment, and then you need to prepare for the lab report by answering all those questions asked you in the lab manual. Okay, so that's including the preliminary question. Okay, so all of the preliminary questions from 1 to 9, and then the experiment 1, you need to answer that. Okay, this what is the average of the measurement, the deviation, the standard deviation, and the error of the measurement, and then write the measurement with the uncertainty. All right, so that's the task. Okay, and then also question number 12. All right, and then you need to answer the experiment number 2. Okay, got the question there, and then also for the third experiment with the Gaussian distribution. Okay. All right, so that's it for our lab session for today. Okay, so any question before I stop?
Do we need to recopy all the questions or we just answer?
Pardon, Kailan?
For all those questions, right, including the preliminary questions or the experiment question, do we need to recopy the questions or just write down the question number and then we just answer?
You can just write down the question number.
Okay, okay. All right, thank you.
But make sure you separate that with a section. Okay, so let's say this is section for experiment 1 to agree, and the other one for the preliminary question. Okay.
Okay.
All right. So any other question? All right. So it seems there's no other questions. So before we stop, so let's take attendance for today. Please turn on your camera. Okay, I'm gonna count from 10. So, all right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and smile. Okay, thank you everyone. So enjoy the rest of your day. All right, so I see you again on Thursday. Okay, have a good one. Okay, bye-bye.
Thank you,
Assalamualaikum.
Doctor.
You're welcome.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.